The birth of stars is a complex and beautiful process that occurs within massive clouds of gas and dust known as nebulae. These clouds can be found in various locations throughout our galaxy, from the vast stretches of gas between the stars to the dense cores of molecular clouds. As these clouds collapse under their own gravity, they begin to heat up and spin faster. This causes them to flatten out into a disc-like structure with a central bulge forming in the center. Within this bulge, the conditions become so extreme that hydrogen atoms begin to fuse together, releasing vast amounts of energy in the form of light and heat. This process is known as nuclear fusion, and it is what powers all stars. As the fusion reactions continue, the pressure and temperature inside the protostar continue to increase. At some point, these forces become so great that they push back against the gravitational collapse, creating a stable equilibrium between the inward pull of gravity and the outward push of radiation and gas pressure. At this point, the protostar becomes a true star, which will continue to shine for millions or billions of years. However, not all protostars are successful in becoming stars. Some are too small or too cool to sustain nuclear fusion and simply fade away into oblivion. Others may become brown dwarfs, which are objects that are too small to ignite sustained fusion reactions, but still emit heat and light as they slowly cool over time. The birth of stars is a fascinating and ongoing process that continues to be studied by astronomers and astrophysicists around the world. We have much to learn about how these objects form and how they continue to evolve and change over time. But one thing is certain: the beauty and complexity of the universe never ceases to amaze us. Hello and welcome to The Cosmic Adventures of Hanuman. I am your host Hanuman, and with me is ChatGPT, an AI language model created by OpenAI. Today we will explore the birth of stars, one of the most fascinating phenomena in the universe.
Indeed, Hanuman. The formation of stars is a complex and intricate process, involving the collapse of massive clouds of gas and dust. As these clouds collapse under their own gravity, they heat up and eventually ignite, giving birth to a new star.
But how do these clouds of gas and dust form in the first place? And what determines the size and characteristics of the resulting star?
Great questions, Hanuman. The answer lies in the composition of the universe itself. The universe is made up of different elements, such as hydrogen, helium, and heavier elements like carbon and oxygen. These elements are created in the hearts of stars through nuclear fusion, and are scattered throughout the universe when the stars eventually die.
So, when a cloud of gas and dust collapses, it is made up of these different elements. But how do these elements come together to form a star?
The process begins with the gravitational collapse of the cloud. As the cloud collapses, it begins to spin, forming a disk of material around a central core. This disk is called a protoplanetary disk, and it is where planets and other objects can form.
And what determines the size and characteristics of the resulting star?
The size and characteristics of the star depend on the amount of material in the protoplanetary disk. A larger disk will result in a larger star, while a smaller disk will result in a smaller star. Other factors, such as the temperature and density of the disk, can also influence the size and characteristics of the star.
Fascinating. And what about the different types of stars like red giants and white dwarfs?
Those are the result of the later stages of a star's life cycle. As the star consumes all of its fuel, it undergoes a series of transformations that can result in different types of stars.
Amazing. Well, that's all the time we have for today. Thank you for joining us on this journey of exploration and discovery. We hope you'll join us again for another exciting episode of The Cosmic Adventures of Hanuman.